Good morning, respected teachers and my dear friends. My name is Mohammad Salman. I am from Mechanical Engineering. Our topic name is intrinsic semiconductor. The subject name is engineering physics. This is CA2 assignment. What is intrinsic semiconductor? Today I would like to explain about it. A pure semiconductor and its conductivity is low. Intrinsic semiconductor energy band diagram and its thermally generated current scaries. Example of pure and intrinsic semiconductor used frequently are germanium and silicon. Intrinsic semiconductor. In the figure 1, the thermal generation a valence of electron accrues some extra energy and the moves into random band. Physical picture or bond diagram. In B, the energy diagram, it recommended an electron from condition band falls into a hole in valence band and both the electron and the hole disappear. It is also possible for an electron to lose energy by holding with something, in which case may remain the condition band. In collage case, the electron continues to exit. We can see on the screen germanium silicon image. At K, all the covalent bonds is completed. Therefore, no free electron is available in the crystal for condition of current. Hence, silicon crystal behaves as insulator at K. At room temperature, the covalent bonds break and electron becomes free. The electrons which leave bonds is called free electrons, and the vacancy created in the covalent bond due to the release of electron in the hole. If the potential difference is applied across and insulates semiconductor, electrons will remove towards the positive terminal, which the holes will drift towards the negative terminal. The semiconductors are chemically pure. In the words, the free from impurities are termed as intrinsic semiconductors. You can see the image intrinsic semiconductor right side. It explains the semiconductor is in pure from non-intrinsic semiconductors. Example, pure germanium, pure silicon. Semiconductors that are chemically pure, in the other words, free from impurities, are termed as intrinsic semiconductors. In this intrinsic semiconductor, we can see the energy band diagram. The doping of impurity. The doping of impurity or additional of impurity does not take a place in intrinsic semiconductors. Density of electrons. Now, the number of free electrons in the condition band is equal number of holes in covalent bond. Electron conductivity. Electron conductivity is low. Position of Fermi level midway between VB and CB. Example crystal from pure silicon and pure germanium. Here we can see the total current inside the semiconductor equals to current due to free electron plus currents due to holes. The process of adding the suitable impurities in the intrinsic is called doping. The impurities added in intrinsic semiconductor to increase the conductivity are known as doped. A semiconductor doped after the adding impurities atom in an intrinsic semiconductor is called extrinsic or doping. You can see the the image on the screen which explains the graph. Drift mobility in centimeter square. The variation of the mobility with the doped concentration in silicon and the electron and holes. The blue line represents the holes and the red line represents the electrons. In this topic, hole as carries transport in semiconductor. You can see the right side the holes which explains about the electrons flow from the holes. Free electrons. Hole as the carrier transport in semiconductor. Hole is the absence of electron and covalent bond is called hole. The absence in the semiconductor is not only due free electron Cb but also due to valence in electron Vb. Bound electrons. The valence electrons taking part in bonding process is called bound electron. The electrons already in the bonding process can participate in condition because presence of vacuums and or holes. The bond electrons tend to move through vacuums and contribute to current. Conclusion. Here we learn about to speak English and the shape, what we can do and determine what we can think about. Thank you. Thank you very much.